Hey everyone, welcome to my channel. I have started a personal DSA challenge where I am solving 5 problems per pattern, covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you are new here, you can check out the previous videos to follow along. In today's video, we'll work on permutations. So the problem states that we are given an array of distinct integers and we need to generate all the possible orderings of those numbers. So this is one of the important backtracking problems on lead code. And if you understand this problem, you'll unlock a huge chunk of recursion plus backtracking questions. So yeah, we will return all the possible permutations. So the intuition is, for the previous question subsets, we used the approach like either we pick it or we will not pick it. For permutations, we will pick one from remaining choices each time. So at every step, we choose an unused element, add it to the current path, we will explore further and undo. So this is a classic approach like choose, explore and undo. The same thing which we did in the previous problem subsets. So we will start with an empty list and we will choose the available elements, and then we will pick one, and then we'll pick the remain. Okay, let me write the code. So we maintain the current permutation, which is we maintain the current path, and we also maintain a visited array to avoid reusing, and we also maintain a result list. Okay, let me write the code instead of all these explanations and words. So let's initialize this array list as result, new array list, and to track which elements are already used, we will declare a boolean array used and new boolean nums dot length size, and let's call the method backtrack, and we will pass the input nums, this used array, and we will also pass a new array list for the current list and result. Now at the end we will return result. Okay, now the return type is obviously void because we don't need anything. Let's implement this backtrack method. What did we pass? We passed input nums, and we passed used boolean array. This is called used, and then we passed a new array list for tracking the current path. Maybe we will take it of type list and let's call it current, and we passed list of type integer result. Okay, oh, 1 second. Okay, now so the base condition is if we reached the maximum length nums dot length, then that means the permutation is complete. So we will check if the current path size is equals to the length of the given nums, then we will add it to the result, new array list of current, and then we will return. Okay, now we will try each and every element. For that, let's take a for loop starting from 0 less than nums dot length I plus, and now We will skip if already used in if already used element is there in the current permutation, then we will skip it. So for that, since it is a boolean type, we will check if used of I. If this is true, then we will continue. And I would say skip if already used. Now let's go to our approach. Choose, explore, and undo. So for choosing, we will update the current element to true, and we will add it to the current path, nums of I. Right? This is for choosing. Now we will explore. For exploring, we will call this backtrack method, and we will pass nums, used, current, and result. This is for exploring. Okay, now to undo, we will remove it from the current path, current dot remove of the last one, so it would be current dot size -1, and we will make used of I back to false. So this is for undoing. This is nothing but backtracking. Right? Let me run the code. Okay, it is accepted. Let's submit it. It is accepted. So coming to the time and space complexities, the number of permutations of n elements is n factorial. So since we are doing it for n elements, the time complexity would be n into n factorial. So permutations take n factorial, but why did I say n into n factorial? Because copying each permutation takes O of n. So here if you see, we are adding it to the current, and also we are adding it to the result. So that's why we are doing it for the n times. So that's why we the time complexity would be n into n factorial, and the space complexity would be O of n for recursion depth and O of n factorial output space. This one. So if that is considered, then it would be O of n factorial output space. Otherwise, if only the recursion depth is considered, then the space complexity would be O of n. So this problem introduces ordering based backtracking, and this is used in many advanced problems. So if this clicked, you have officially entered the backtracking zone. Next we will see other problems in the upcoming videos. So you can dry run for a simple example, and it would be easy to understand. So that is it for today's problem, and I will see you in the next one.